Welcome to everyone. I'm here to present I'm here to present a seminar video on a random process. So, first of all, we know about the random process previously. The random process is a probability theory and distributed process. Here is the introduction about the random process. So, a random process is a collection of random variables that evolve over time. So unlike deterministic signal, where the future values can be predicted exactly from the past data, a random process exhibit uncertainty, meaning we can only describe it in probabilistic terms. So in simple terms, if we observe a system repeatedly under identical conditions but get different outputs each time due to randomness. So the output is modeled as a random process. For example, thermal noise or speed signal or stock market price and weather variations. So in the thermal noise in electronic circuits and speed signals, though they have patterns, exact waveforms cannot be predicted. Hence, random processes are vital for modeling systems. So, modeling systems affected by unpredictable factors. So, mathematically, it is represented as capital X of t. It represents a random process. When for each time of t, capital X of t is a random variable. So, conversely, for each outcome in the sample space, capital X of t defines a time function or waveform. So a random process, also called stochastic process, is a collection of random variables, as we said earlier. So when you say random process modeling, unpredictable phenomena such as thermal noise, fading channels, and random bits errors. So, so we can talk about the mean variance or correlation evolve with time and are essential for analyzing signal integrity, noise performance, or receiver design. So this is the brief information about the random process. Next, we can talk about formula, definition, and examples. So formula for this random process is defined as a family of random processes. Capital X of t, comma. So mathematical definition, if omega is an element in the sample space, yes, then x of capital X of t comma omega. So for fixed t comma small t comma capital X of t is a random variable. For fixed omega comma x of small t comma omega is a time function or a sample function. For example, toss of a coin. Let's consider a random process defined as the capital X of t is 1 comma if heads at time 0 comma if tails at time t. So another example we can talk about. So thermal noise. So thermal noise is a register varies with the time and cannot be predicted exactly. cannot be predicted exactly. Its amplitude at any instant is random but characterized statically by mean and variance. So these examples shows how random process describes uncertain but statically predictable behavior. So here is the formula, and we are talked about the examples also. So next we can move the classification of random process. Mainly, these are classified into four types: continuous time, continuous state, discrete time, discrete state. So we can talk about the classification of a random processes. A random process can be classified into uh, different categories based on the amplitude or nature of random variables. These are it means these are classified into two types: discrete random process. So the random variable takes discrete values, for example, number of customers arriving per minute. So another one is continuous random process. So the random variable takes continuous values, for example, amplitude of thermal noise or voltage variations. And next, based on time index set, so these can be classified into two types. So discrete time random process and the continuous time random process. So first of all, we can talk about the discrete time random process. The process is observed at discrete time intervals, t equal to 1, comma 2, comma 3, comma 4, or etc. For example, daily stock prices. So the second one is a continuous time random process. The process is defined for all t. For example, noise voltage over time. So and the next one, based on a stationary, these can be classified into two types. So stationary process, non-stationary process. First of all, we can talk about the stationary process. The statical, the statistical properties like mean, variance, and autocorrelation do not change with time. It's known as a stationary process. Uh, For example, thermal noise with constant power is the example for the stationary process. So, and next one is a non-stationary process. So, the statistical properties vary with the time. For example, mean, variance, or the autocorrelation can be changed with the time. It defined as a non-stat uh, stationary process. For example, speech or traffic signals. And based on the ergodicity, it can be classified into two types: ergodic process and a non-ergodic process. Uh, First of all, we can talk about the ergodic process. The time averages equals ensemble averages. It is known as ergodic process, and non-ergodic process means time averages and the ensemble averages differ. So these classification helps in analyzing the random process and a different context in signal processing and communications. So next one, we can move. So next topic is the deterministic and the non-deterministic process. So let's now understand the fundamental difference between deterministic and non-deterministic process. Non-deterministic random process. So first, talk about the deterministic process. The output is completely specified and predictable for every instant of time. So there is no any randomness in is involved in this deterministic process. So mathematically, it can be uh, mathematically the expression of signal is exact and repeatable. For example, small x of t equal to 5 sine 2 pi 50 t, something like that, or s of t equal to a cos omega t plus pi. And next, we can talk about the non-deterministic random process. So, first of all, future values cannot be predicted exactly. Only statistical characters can be known. For example, thermal noise in electronic circuits, thermal noise N of T in electronic circuits, even though its instantaneous values is unpredictable. So its average power and autocorrelation are predictable. So thus, deterministic processes are ideal models, while a random process represent a real world unpredictable phenomenon. So the major difference in these deterministic and non-deterministic process is so predictability. It means exact random statistical. Okay. Next, analysis. Deterministic can be with the equation, but a random does not probabilities only. Next example, sinusoidal for deterministic and a noise for non-deterministic. These are the key differences between the deterministics and the non-deterministic process. Next, joint probability density function. So here is the information about the joint probability density function. So when we analyze random process, we often need to study the relationship between values at different time instance for any two variables. Uh, for example, capital X of T1 and capital X of T2, the joint density, sorry, the joint probability density function is defined as fx of T1 comma x of T2, x1 comma x2. So it gives the probability that capital X of T1 is equal to small x1 and capital X of T2 is equal to small x. So the function must satisfy if function is said to be joint probability density function, it must satisfy the equation. So the equation is fx f x of t1 comma x of t2 of x1 comma x2 is equal to fx of t1 of x1 fx of t2 x2. So this function helps us to understand how values of a process at a different time are correlated or dependent. So this is the joint probability density function, capital PDF. So next we can talk about joint cumulative distribution function. So the joint cumulative distribution function, capital CDF of a random process is defined as capital X, so capital F, x of t1 comma x of t